So this is the last question of the MTH240 midterm, and it is question 7. It is another differential equation problem, and it says solve the following differential equation. Solve explicitly for y of x. So in this problem, we just have to find the general solution. And so the first thing we want to do is we want to check whether this differential equation is separable. As I once previously mentioned in the video I made for question 3, where we had to do an initial value, I stated that separable is a easier method typically. And so that's why you typically, if it doesn't say or it doesn't state what type of method we have to use, we want to check for whether or not it is separable. So how do we check that? All we have to do to check whether it is separable or not is see if we can get all the y's on one side and all the x's on one side. And so let's go ahead and dive right into this problem. So the first thing we can kind of see is we have this polynomial in the brackets, and we can actually go ahead and factor this on the side. So let's just quickly factor this. So we have x squared plus 3x plus 2 is equal to 0. Our product is equal to 1. Our sum is equal to 2. What are our two numbers that add to 2 multiply to 1? That is going to be 2. And oh, I made a mistake. The product is actually 2. And the sum is 3. What am I doing? Okay, so yeah, it is 2 and 1. So if we factor this, essentially we will get x plus 2, x plus 1. And so that is that factored. Okay, so then now let's go back. So now that we factored that, let's write that down. X plus 2, x plus 1 times y prime, so times y prime, is equal to y. Okay, so now we want to get all the y's on one side and we want to get all the x's on one side. So what can we do? Well, the first thing we can do actually is we can do some cross multiplication. Well, what are we going to do the cross multiplication? These are all over 1, right? Well, what we can actually do is this y prime right here, we can actually change this into dy over dx. So we can rewrite this whole thing as x plus 2, x plus 1 multiplied by dy over dx, and that is equal to y. And so now we can technically do some cross multiplication. Let me rewrite this so that it's more clear. We can write it like that. This y is technically over 1, so let's do cross multiplication. And so what does that give us? That gives us x plus 2, x plus 1. And then that gives us a, oh, let's not forget that dy. And then we have a y dx. Okay, so we're almost done. Now we just have to get that dy to the y side and the dx to the x side. So what we can do then is we can, let's first move this dy. How can we move that? Well, what we can do is we can multiply this side by 1 times y. Because if we do that, 1 times y, this and this cancels out, 1 times y. And so we will then get this. Okay, so we've done one thing. We have got rid of the y's on the right side of the equation. What about this dx? Now that this dx is alone, all we have to do is we want to multiply this side now. Let's copy this. So let's make this more clear. So this is what we have. And now what we can do is we can multiply what we want to do is we want to move this right here to this side, to the dx side. So we can multiply both sides by 1 over x plus 2 x plus 1. That way this and this cancels out, and then that leaves us with 1 over y dy is equal to 1 over x plus 2 1 over x plus 2 x plus 1 dx. And we want to make sure that the dy and the dx are not in the denominator, because if it's in the denominator, we won't be able to proceed with the next step once we've actually reached this point. And that next step is to integrate both sides now. So what we actually have to do now is we integrate. So we would have to integrate 1 over y, and we would also have to integrate this 1 over x plus 2 times x plus 1. So we know that 1 over y, this is a very simple integration. We know that this would just simply be equal to ln y. And so now this, we're going to have to integrate this. But how do we integrate this? We're going to have to use partial fraction decomposition. So 1 over x plus 2 x plus 1 is going to be equal to a constant over x plus 2 plus another constant over x plus 1. And so we need to find these constants, and so we can evaluate that by essentially multiplying the denominator to 1, to a, and to b. If we do this, we will get the following. 1 is equal to a x plus 1 plus b x plus 2. And so now we need to try some x values to see how we can solve and find a and b. So then, let's make some more space. Actually, no, we'll continue on to the next page. So let's try at x is equal to -1. So 1 is equal to a times -1 plus 1, which is equal to 0, and 0 times a is 0, and then plus b -1 plus 2, that is 2 minus 1, so it is 1, and so that means b is equal to 1. So now let's find a. X is equal to -2. You can try -2. And so that would mean 1 is equal to a -2 plus 1. That would be -1. And then -2 plus 2, that is equal to 0. So that means our a is equal to -1. So we found our constants now, so we can rewrite this, and then we can then go ahead and integrate. So let's get a new page. copy this down. And so this is going to be our a is -1, -1 plus 1. And so now we have to integrate this. And so we can actually then split this integral into we can split it like this. Or you could leave it because this is a pretty simple integration. We're just going to end up getting ln natural log absolute value of x plus 2 plus natural log of x plus 1 plus c. And so there we have that. So now that we've found this, if you recall, we were trying to solve this right here. And now that we found it, we have integrated both sides. Let's continue with the process. So this is equal to ln y equal to negative x plus 2 plus ln x plus 1 plus c. And so we want to get rid of the natural logs. So how can we get rid of the natural logs? Well, all we have to do is raise everything to the power of e. So e to the power of ln y, which is equal to e to the power of negative ln x plus 2, and that would be multiplied to e to the power of ln x plus 1 times e to the power of c. Now we can see that we have this e to the power of c, which would mean e to the power of a constant. And technically, this is just another constant. So we can just rewrite this as c, or any other variable really. And what else? Okay, well, we can see that e and natural log cancel out. So this would cancel out, this would cancel out, and this would cancel out. And that would leave us with y, the absolute value y, is equal to 1 over, or well, it would be equal to 1 over x plus 2, because this negative right here, I should have actually wrote that, this negative technically is the equivalent of this. And we know that this expression right here is technically 1 over x plus 2. And so that's why we have 1 times x plus 2, and then we have times x plus 1, and then times our constant c. So we can then rewrite this, and let's add this x plus 1 to the numerator. And so that would give us the absolute value of y, which is equal to x plus 1 over x plus 2 times c. And so we can now write our final answer. Y is equal to x plus 1 over x plus 2 c. And that is how we would solve this differential equation.